All right, welcome to this explainer. Today, we are tackling an absolutely massive, heavy-hitting topic for your computer science exams. Specifically, we're diving deep into virtual reality headset principal operations. Now, I want you to think of this specific topic just like a competitive weightlifter approaching a massive, loaded barbell on the platform. You see, mastering complex VR questions isn't just about throwing your weight around or flexing how much you've memorized. Not at all. It requires explosive bursts of analytical thinking and absolutely perfect form. If your form is off, you're dropping the weight, and in this case, you're dropping crucial marks. Nailing the setup, getting your grip right, that means acing this paper. And listen, whether you're taking syllabus codes 0417, 0478, 0983, 0984, 2210, or specifically focusing on the heavy-duty 9618 Cambridge AS and A level, the core strategy we're going to talk about today is your golden ticket. It's the exact form you need to lift those heavy, high-mark questions without breaking a sweat.
So, here is our roadmap for today's session. First, we'll define the challenge. Then, we'll build your core foundations. After that, we'll outline a strict procedural framework. Then, we get to the fun part, an interactive workshop where we put it to the test. And finally, we'll wrap up with the final system and crucial examiner warnings.
Okay, let's jump straight into Section 1, the challenge, the VR heavy lift. We really need to look at the actual stakes here when it comes to these dense VR headset questions. So here is the big question. Why do so many incredibly well-prepared, smart students stumble right here? You've read the textbook, you know what a VR headset is, so what gives? Well, it really comes down to two specific types of bad lifting form that we see constantly in the exam room. It's almost like a psychological trap. First up, we have our student persona, Alex. Now, Alex is a hard worker, but under pressure, Alex overloads their answers with raw, unfiltered computer science facts. They'll write paragraphs about screens and sensors and pixels, but they offer zero actual analysis. It's just a brain dump. Then, on the other side, we have Sam. Sam definitely knows the material, maybe even better than Alex, but Sam rushes. Sam gets hit with the exam adrenaline, completely misses the specific command word requirements hidden in the question, and just writes a generic response. So what's the issue? Both of these approaches entirely lack the precise, targeted, analytical depth that the Cambridge examiners are actively hunting for.
And honestly, this brilliantly illustrates exactly why you cannot afford to have that bad form we just talked about. Look at this number on the screen, 15%. Virtual reality headset principal operations accounts for approximately 15% of the total marks in Paper 2. Let that sink in for a second. That is a massive, massive chunk of your overall grade. This isn't some tiny, obscure side topic that you can afford to skim over the night before. It is a core pillar of the entire syllabus. We're talking about the difference between a B and an A star right here. If you are aiming for those absolute top marks, and I know you are, you have to conquer this 15% with absolute precision. You can't just kinda know it. You have to dominate it.
Moving right along to Section 2, Core Theoretical Foundations. Just like our weightlifter needs a rock-solid base and perfect form before even attempting a personal record, you need a flawless theoretical architecture.
Now, what's really fascinating about what we're looking at here is how it perfectly contrasts two entirely different approaches to the exam. Remember Alex from a minute ago? Alex uses a strategy we call superficial breadth. It's basically throwing every single fact you've ever learned about VR headsets onto the paper and just praying that something, anything, sticks. But here is the hard truth. The Cambridge Assessment Framework actively penalizes this. It's a waste of your time and the examiner's time. What they actually prioritize, what they actually give marks for, is analytical depth. You need precise technical definitions, and more importantly, clear causal relationships. A leads to B, which causes C. Furthermore, and this is a huge secret weapon, principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. What does that mean? It means showing how VR concepts, like say rendering engines or refresh rates, integrate with other syllabus areas. You have to demonstrate a fully connected conceptual understanding of computer science, not just isolated flashcard memorization.
Which brings us right into Section 3, Mastering Procedural Frameworks. We're going to break down the exact mechanical execution of your answer. But before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's get into the mechanics. When you are tackling an algorithmic thinking question regarding VR headsets, you must, and I mean absolutely must, follow this exact 5-step sequence. Think of it as your muscle memory. Step 1, deconstruct the question. Rip it apart. What is the command word actually asking you to do? Step 2. Extract the relevant data from the scenario. Filter out the noise and grab the variables that matter. Step 3. Select your analytical framework and the appropriate data structures. Are you using an array, a linked list? Decide now. Step 4. Execute your efficient code implementation or logic using incredibly clear notation. This isn't the time to be messy. And finally, Step 5. Present your findings with rigorous testing and correct technical terminology. Step-by-step decomposition is absolutely non-negotiable here, guys. If you try to skip from Step 1 directly to Step 4, your whole argument collapses under the weight of the question. You have to build it block by block.
And here is where we introduce the ultimate secret weapon, the method mark strategy. In the Cambridge 9618 syllabus, marks are incredibly highly weighted towards your process. You earn your marks by demonstrating correct logical processes and algorithmic steps, not just by magically arriving at or randomly guessing the final answer. The examiner wants to see how your brain works. To guarantee you capture every single one of these method marks, top-tier students use the PEEL framework. Point, evidence, explanation, link. It's brilliant in its simplicity. You make your point clearly. You provide evidence extracted straight from the data. You explain the algorithmic logic connecting them. And finally, and this is the part people forget, you link it directly back to the specific VR context of the question. If you do this, you are literally forcing the examiner to give you marks.
Now we're getting to the really good stuff. Section 4, the Transformation and Interactive Workshop. Let's see how this PEEL framework builds in real time to transform weak, flawed answers into perfect, high-scoring responses. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump right into challenge number 1, your data scan. Imagine the clock is ticking down in the exam hall. Evaluating algorithm quality in a VR context requires you to map these specific criteria under extreme pressure. Let's look at the table. First, time complexity. This dictates execution speed, which is absolutely crucial for processing VR frame rates without any nauseating lag. If it's too slow, the user experience is ruined. Next, we have space complexity. This is all about the memory limits physically built into the headset's hardware. You don't have infinite RAM in a portable headset, right? You have to optimize. And finally, edge cases. This dictates overall system stability. If your VR headset encounters a totally unexpected sensor input, maybe the user spins around too fast or walks into a wall, the system shouldn't just crash. It needs to handle that boundary condition. If you can't mentally map this out instantly when you read the prompt, your lift will fail before it even begins.
All right, challenge 2, find the flaw. I want you to read this sample answer on the screen. It says, the VR headset updates the display fast so the user doesn't get sick. I want you to actively think right now, why does this answer violently bleed marks? Look at it closely. It's exactly the kind of answer our buddy Sam writes when he's rushing against the clock. Sure, it shows a very basic layman's understanding of what a VR headset does, but it entirely lacks precise definitions. It lacks comparative analysis. It completely misses the technical methodology that the syllabus explicitly demands. Updates fast, doesn't get sick. These are conversational terms, not computer science terms. It is way, way too generic. The examiner is going to read this, sigh, and give it 0 marks. But now, look at the transformation. Here is the fixed version. Boom! The VR headset requires low latency and high refresh rates to process continuous edge cases, preventing motion sickness. Do you notice the massive difference in quality here? We took updates fast and replaced it with highly specific technical terminology, low latency and high refresh rates. We elevated doesn't get sick to preventing motion sickness. And most importantly, we brought in the crucial concept of processing continuous edge cases to explicitly show the examiner our algorithmic depth. We are proving that we understand how the hardware actually interacts with the software environment. This is exactly how you use the PEEL framework in practice. You ensure that the examiner has absolutely no choice but to award you full marks because you've ticked every single technical box.
Let's move into our final and perhaps most important section. Critical evaluation skills and examiner insights. We are bringing in the spotter's advice straight from the Cambridge Principal Examiner reports. Read this quote very, very carefully. The principal examiner says, The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Guys, this is the ultimate examiner warning, delivered with absolute, unquestionable authority. These are the people literally grading your papers and deciding your future, telling you exactly where the heaviest lifts go terribly wrong. If you just memorize a textbook definition of VR operations, even if it's a perfectly accurate definition, but you fail to apply it to the highly specific scenario provided in the prompt, you will lose the marks. It's that simple. Context is king. Context is everything.
Breaking this down even further, here are the top 3 explicit examiner warnings that show up year after year after year. First bullet, answers are just too vague. As we saw with Sam, examiners demand specific technical details. You must use the vocabulary of the subject. Second bullet, students consistently, almost predictably, forget to check boundary conditions and edge cases when evaluating algorithm quality. You have to prove the system won't break. And third, reinforcing what we just discussed, answers are not specific to the given VR context. Applying your technical knowledge in a vacuum without situational context is a guaranteed 100% surefire way to drop your grade boundary. Don't fall into these completely avoidable traps.
So to help you retain this entire strategy under the intense, sweaty pressure of the exam room, I want you to memorize this simple, powerful memory hack, the Visser method. Ready? V stands for verify the context of the question. I stands for identify the boundaries. S is for select the appropriate data structure. O means optimize for time and space complexity, and R is rigorously test your edge cases. Visor. Whenever you sit down, flip open that test booklet and see a question on virtual reality headset principal operations, I want you to mentally visualize the Visor acronym before you even think about picking up your pen to write a single word. It will guide your entire answer.
So I leave you with this final provocative thought. How will you actively integrate specific context into your very next past paper practice session? Don't just nod along right now and forget about it. Make a concrete plan right this second to permanently change your study habits. Because honestly, implementing these exact strategies is the absolute difference between just passing and truly excelling. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.